lucky that it's rewriting stuff that I want to do because sometimes this is like because I don't have something on.
All right, everyone. Sorry I'm late. We had an interview run a little long. But this afternoon, we're going to be talking about Node. And we're going to be doing a bunch of asynchronous stuff, which means we should probably talk about what either of those things are. So I've used it now and again when we're doing demos in live codes. You see me like launch Node. Who has a sense of what Node is?
Kind of.
Kind of?
Yeah.
Go for it.
No, not really.
No.
I just know it involves like the file system and stuff like
It
that.
does.
I've
Yeah.
never really used it before, but I don't think I can explain what it is.
Okay.
So,
When you used it, what did you do with it?
like instead of doing stuff in the console, I'd like run my files in terminal and then with Node. And
Yep. Yeah.
So it's just like running your code.
You got it.
right?
Yeah.
I mean, yeah. The compiler, I don't know.
Yeah, so it has a compiler. It's kind of doing the thing a browser does to JavaScript,
Right.
but not in a browser. Yeah, that's exactly it.
Yeah.
So, okay, a bit of background first. JavaScript was invented in 1995 by someone who it turns out is not a great person. But that's okay. For years, it was kind of a toy language. People started using it to do like little animations on web pages. It was called JavaScript actually, despite having very little to do with Java, because at the time Java was the big hot thing. And they were like, okay, we'll like ride on the coattails of this real language that you would actually use to make like fancy web experiences. And we'll just be around for like, I don't know, animations, or if you want to like generate a little bit of content or something. We wouldn't use JavaScript for everything. And cut to 2009, we're using JavaScript for everything, literally everything. You can write robots in JavaScript at this point. And the intervening years are really a story of, there's an essay that's rather famous called Bad Beats Good, I think, or something to that effect. Basically saying that if your thing is like maybe not so great, but it's pervasive, it's almost certainly going to win out technologically over something that is maybe in some objective sense better, but is not nearly so widespread. And that's exactly what happened with the web. JavaScript got into web pages, people started realizing there's like a bit of stuff you can do with it, and then like web browser manufacturers added some features to it because it was kind of useful, but it would be more useful if you could like, I don't know, make requests to the server. And then once you can make requests to the server, oh, it would be nice if you could sort of manipulate the tree of the document a little bit more easily. And then after you add even not that many features, you start to be able to do a lot of like very complex things. It's hard to do, like you have to write a lot of JavaScript, but it's possible, and it means that as long as the person using your site is using the newest web browser, which is obviously Netscape Navigator 4.0, then they'll be able to like see and do all this cool stuff. So browser manufacturers started to make JavaScript more and more complex, and then also have a little war with each other over who can make it faster. And that competition means that now JavaScript is the fastest scripting language. That is a language that isn't compiled beforehand, doesn't have explicit typing, and I'm gonna say that those are the main criteria. Like that, what actually defines a scripting language is a pretty open question. But Java is probably the fastest such language around because there's all like Google and Apple and Microsoft are basically all fighting to make the fastest JavaScript engine. So around 2009, like JS is very fast. Chrome has a very fast JavaScript engine inside of it called V8. And people are like, well, if we have this very fast scripting language, maybe we can replace Ruby with it. At the time, like the big hot technology, and still a very prevalent technology for web servers, was Ruby, and specifically Ruby on Rails. And Ruby on Rails has a lot of nice features. If you use it, I'm sure you'll find some things to like. At this point, it's so big, it's a bit like doing your taxes more than programming. But people started to ask, like, okay, could we actually use JavaScript, use this engine that Chrome put into, or that Google put into Chrome, and run the server with it as well, and would we see performance benefits? And the answer turned out to be yes and yes. And the project that proved those things was Node. And it's still the project that we use for JavaScript on the server today. So what is it? It's a JS runtime environment, which is maybe not very helpful. So it's a tool that lets you run JavaScript directly on an operating system, kind of without a web browser in between. So whereas in Chrome or in browser land, you put your JavaScript inside of script tags or reference it from script tags. Like you put it at a URL and then point the script tag to it. In Node, you're just using files. So you put your JavaScript in files, and then you can run them with the Node command. And whereas in the browser, you have certain built-ins like window and history, which is the browsing history, and document, which refers to the current document, the root of the DOM. In Node, we don't have a window, we don't have a browsing history, we don't have a document. So instead, we have, excuse me, we have built-in primitives, or in some cases modules, that help us work with the things we do have. Things like a process. So a process is the sort of container that a living program is sitting inside of. And Node gives us access to it. So you can do things like, you can ask what were the arguments that were passed to my process on the command line when it was invoked. Or you can ask, what is the environment my process is being run in? That's a bunch of variables that you can set up in your shell that get passed into every program you invoke with it. It's how your shell can, for example, know where your home directory is, or know what your username is, or know what sort of terminal it's running in, so it can know whether to display colorful output or not. And then Node also gives us a bunch of modules to access things that we can't access in the browser. So like there's an FS module, which gives us access to the file system. There's a net module, which lets us directly open connections to servers and become a server ourselves. There's about like 50 other built-in modules, many of which do things that you're not allowed to do inside a browser because it would be a living catastrophe. Like, nobody wants the FS module to be available inside a browser, at least not in its like raw, unrestricted state, because that is like the definition of a major security flaw. It's like fs dot read all your files and send them to someone who's gonna do God knows what with them. There's also a lot of similarities, right? So they both use JavaScript. They both, these will be slightly different versions of the V8 engine. That is, like, their V8 is constantly being developed, and Node will pick up the latest version periodically, and so will Chrome, but they're not necessarily totally in sync. But for the most part, like when a new feature, a new JavaScript feature is supported in Chrome, it gets supported in Node as well. And then a lot of like basic primitives are shared. So like set timeout, set interval, what else? Okay, definitely those. Definitely timing functions. I'll think of some others, but like some of the core bits, math, array, all of the like really core JavaScript language features we've come to know and love, those are in both. Those are implemented by the engine. Okay, so why do we care about Node? Why do we want to care about Node? What are some things that Node lets us do? Sorry. Yeah, so access the file system. Yeah, run JavaScript. It lets us create servers. So if we know JavaScript and we want to create a server, Node is a pretty good choice. Some people will say like there are better choices. There are faster choices, and there are. In the realm of sort of dynamic scripting languages, there really aren't. So JavaScript is certainly not a bad choice. Why might I want to create a server? Well, you might want to create a custom website or a web app, and you might need to do something on the server. You can create a website without running a server at all, right? Does everyone know that? Sort of. There's.
What is a server? I know that's the most basic question. But what is
Oh,
a server?
we will totally look at that. So a server is a program that listens for incoming network requests and handles them somehow. So a web server listens for incoming HTTP requests and responds to them. So at the end of every browsing interaction you have, there's a web server that's listening to the requests from your browser and serving up data. So being in control of the server gives you a lot of control over what happens on the site. In fact, gives you the highest degree of control you can have. You can serve up whatever content you want from a server that you've written, and the browser will do its best. Well, the browser will do whatever it does with it, but it will generally do its best to render it. Excuse me. Oh, yeah, so what is a server? It's a program running a computer that serves content requested by remote clients. Do I have anything more to say about that? I don't think I have any questions about that. We'll write a little server here in the next 10 minutes. Because it's pretty easy. Okay. So we're about to embark on a metaphor. It's not my favorite metaphor, but it's an okay metaphor. And that metaphor is if programming were cooking. So if programming were cooking, then your program, wait. Oh, right. I was like, wait, this isn't a metaphor. Okay. Let's talk programming first. So we have our program, which is data. It usually starts as a source file, and then it gets compiled into machine code. Maybe taking a detour through bytecode in some cases. This is rather oversimplified. There are usually several other layers below machine code, believe it or not, and sometimes a couple of additional intermediate layers between the text file and bytecode. But it's the general trend that your program goes from being something very sort of human readable, or as human readable as JavaScript is. You'll find it to be more and more human readable over time, and becomes more and more something that a machine can process. And this is true of every language. It's true of C and C++, where you explicitly invoke the compiler, and you're like, compile this thing, and it creates a file, and you can go look at that file and see the machine code in it. And it's also true of Node, even though that process is kind of hidden from us. When Node or when Chrome loads some JavaScript, it goes through a compilation process where it turns that JavaScript into machine code. Another way of walking through a program is to interpret it. And if you are interpreting the code, you probably do some degree of compilation, but you don't finish turning it into machine code. So instead, you have another program that reads, for example, it reads the text file, would be the most raw kind of interpreter, and it internally does what the program is telling it to do. So it's sort of emulating the rest of the process without necessarily doing it. So as with many things in computers, there's a trade-off here. If you compile your code, it will almost certainly be faster. Not always, but almost certainly. But it takes a lot more memory, and it takes time to do that compilation. If you interpret it, you can get going immediately, but you have this interpreter that has to literally look at each line of the code and be like, what is this telling me to do? I need to go and figure out how to do it. And so it runs much slower. So it's basically a trade-off between time now and time later, and also the memory pressure of having all these intermediate steps that are required to get to the actual machine code, which you also then have to store somewhere. For this reason, actually, it used to be the case that V8 always compiled everything, it is now no longer the case that V8 always compiles everything. There is now an interpreter that on phones primarily, it can be turned on basically on low memory, low power devices. Because honestly, some lines of JavaScript you don't need to compile. Especially like the first bunch of code that runs, it's often code that basically runs to set up the program and then never runs again, right? Like, I'm gonna attach all my event listeners, never runs again. Does it matter if that's fast? It does kind of matter if it's fast, but will it actually be faster to compile it and then run it once? Or would it have just been faster to interpret it and then, like, never touch it again? Yeah?
When you say compile.
Yeah.
What do you mean?
So, yeah, good question. Compiling is going up these layers. I'm sort of wishing that this was written in the other way, but it's going from, formally it's going from one form of a program to another, generally another more machine-like form. In JavaScript specifically, it's going from JavaScript code to machine code. We'll also sometimes talk about transpiling JavaScript, where we take JavaScript code and turn it into JavaScript code, but with some pieces of the code changed to be easier for browsers to use. Basically, in order to provide new features of the language, we will compile them into old features. So it's a process of transforming your program into something that can be consumed. Does that help? Does that kind of make sense? We'll run a compiler and look at the input and output.
Is that React? Compiler? Does that like take JavaScript and runs?
React,
Oh, React.
it isn't a compiler, but it uses a compiler. Or we typically use a compiler, maybe a transpiler if you prefer, when using React. The reason is React has its own syntax for certain things. It has JSX, where you can basically kind of put HTML inside of JavaScript. And the browser doesn't know what to do with that if you just give it to it. So you have to run it through a compiler, we use Babel, that can go and take that syntax and turn it into just JavaScript, something that the browser can understand. And similarly, a compiler, the browser then takes that JavaScript and turns it into machine code, which the processor can understand. And then the processor, like the physical piece of hardware, takes that code and turns it into microcode, which the little processors inside of the processor can understand. And then those processors, I actually don't know how many levels deep that goes, but it's like a lot of them, right? We are standing on top of a teetering tower that may collapse at any moment, as Spectre has shown us. There are so many ways for everything to fail. It's a miracle anything works at all. On that note.
So sorry, can I just clarify? You can, with the process, you can do the compiling as you go. You're just not saving change data.
With an interpreter, you mean? Or
I guess I'm confused.
I actually haven't talked about this yet.
Oh,
really.
right. The program was one that takes memory because you're compiling everything as you go, so you have it all like change from like computer language to what yours.
Or from source to machine code.
Machine. And so what was the two you were saying that one is fast and one is?
Oh yeah, so if you interpret, so you can kind of imagine writing an interpreter, right? Like maybe think about a simpler language which has like has anyone used Logo?
Yeah.
It's like a little language where you tell a turtle what to do. And the commands are like walk forward 10, or it's like walk forward amount, turn left amount, turn right amount, pen up, pen down. Those are the basic commands, and you can tell it to draw things. If you can imagine kind of writing an interpreter for that language, right? You could imagine having like a bunch of if statements. They're like, okay, if the next thing is this, then do this. If the next thing is this, then do this. Writing a compiler for that language would be more like, if I see walk forward, emit this line of JavaScript. So that would be compiling logo into JavaScript. If I wanted to compile it into machine code, it would be, okay, for walk forward, I'm going to emit this machine code when it happens. So the interpreter is going to be a bit slower, but it's not going to have to store that output at any point. Yeah?
I don't think this is like perfect metaphor at all, but I think it's somewhat helpful to think about like literally like a person who's the interpreter between two people who are talking different languages.
Yeah.
Versus like a translator who like translates.
Into, yeah, no, that is a good metaphor, I think. Right, because the interpreter, yeah, actually that's a good one, because the interpreter is like sort of holding all the state of both conversations, kind of. They sort of have to be having two conversations to some extent, to the extent the languages are different, and maneuvering data between them. Whereas a translator translates a book just does it, and now it's in the new language, and any native speaker can pick it up. Yeah, good analogy. So we might call this, back to cooking though, that's a better, I'm going to change this presentation. So back to cooking, we might say that the program is the recipe. So, and this kind of works whether you're looking at it as a text file or as machine code, but if we're thinking about like how operating systems work, which is kind of what this part of the presentation is going towards, let's think about machine code and say that this is like a recipe for something that's going to be made. And then if that's what the program is, then the process is cooking. It is the actual act of doing this thing. So when we start a process, we give the operating system a file. We're like, okay, please run this file. The operating system, if it's just like a compiled binary file, like the kind of thing that sits on in your apps folder and you can double click on, then the operating system throws it into memory, like just literally puts it into a chunk of memory, picks a place, like finds where the program starts by looking it up in, the program has like some way of telling it that. And then it tells the processor, okay, go. It literally executes a jump instruction into that program's data, which is now sitting live in memory, and the program starts to assemble itself. Another, maybe better metaphor is the program is DNA and the process is a living thing, which you'll notice has DNA inside of it that is continuously being read and copied, and it can replicate. So maybe that's not a perfect metaphor either. Or maybe it is, because almost every program we run these days, what is that? Are we gonna die?
Not earlier. Yeah. Ignore.
Okay. I'm gonna ignore it. Because almost every program we run these days, like for example your web browser, is actually kind of doing that, right? Your web browser periodically grabs new DNA, or really grabs new JavaScript, turns it into DNA, and then starts making proteins out of it, right? That's what happens every time you load a website and you see a tab. And you know that because sometimes those little child organisms die, and you get the sad tab page. It's like, oh, I have to reload this tab. Okay. Any more questions? We'll look at examples of this. Okay. Do we have to go through this? Sierra operating system. Okay, I'm going to throw these out here. So,
You're not the one making the
I didn't make the slide. I took the slide, I thought it was a good one at the time, and then now I'm like, I don't know. Some of these are pretty tenuous.
I don't think whoever made the slides is really sure about that.
I don't think whoever made the slide has been in a kitchen, really. Like the interpreter. Okay, wait. Let's stick with it. I think maybe it could illuminate something. So So here's our program. It just logs hi. Okay, this is a recipe. The programming language is JavaScript. Okay, the recipe language, sure. It's English. V8. Okay, so there's a few JavaScript engines. It's probably good to talk about each of these parts at least. There's a few JavaScript engines in the world today. V8 is probably the most used. Safari uses SpiderMonkey. I think that's true. No, Safari I think uses JavaScript core. Microsoft Edge uses some other thing, the name of which I've forgotten. Those are the main ones, and then there's a bunch of smaller ones that are mostly for some specific use case. So there's a JavaScript engine that's designed to be very small and used on embedded devices. There are JS interpreters that are written in Java and JavaScript interpreters that are written in C# in order to run on those respective virtual machines, because that is something that someone has ever wanted to do. Yeah. And the main thing the engine does, of course, is give us the ability to run JavaScript code. It goes from it's handling, like I have some JS source, I'm going to go through all the steps I need in order to make it a running process. So chef is not a totally bad analogy. You know, if you get a chef and put them in a kitchen where you do actually need a bunch of tooling around a chef to make food, and you do actually need a bunch of tooling around the V8 engine in order to make it run. That is Node or Chrome. Node or the browser provides a runtime environment in which the engine can do its thing. So in Chrome, that environment gives it access to a network layer, access to a graphics layer that can draw all the pretty boxes on screen, access to Chrome's like UI and the like user history, cookie store, database, all that machinery that is kind of needed to make a browser a browser. Inside of Node provides much less actually than Chrome, right? Because it doesn't have to provide, for example, a like full graphics stack or the DOM. But it still does provide things, right? It provides a crypto layer, it provides access to the process, and it provides a network interface that we'll look at. And then building the kitchen. It's the kitchen, I think. Oh, no, maybe it's the building. Yeah, so, and then underlying all of that is the operating system, and then the operating system's main job is to interface with the processor, which has its own stack and its own metaphor that I hope isn't cooking. I'm changing this to translators.
Will they also be in the kitchen?
Translators in the kitchen?
They can.
They could be. They very well could be. I think they should be, like, trying to avert nuclear war or something. Yeah.
So like where does the like web browser fit into this? Is it like basically you're using Chrome, you'll be using those sort of packaged together? It's not
Yeah, you can't dig them out. In fact, it used to be that the Chrome and Safari used the same underlying like web engine called WebKit, and that engine supported different JavaScript engines. So you could compile it with support for V8, or you could compile it with SpiderMonkey. I'm pretty sure it's called SpiderMonkey. That like maintaining that abstraction layer, so maintaining the ability to like unplug one JavaScript engine and plug in a different one, was one of the reasons, like the cost of doing that was one of the reasons that Google like split WebKit and made Blink. So Blink is a fork of WebKit. It's mostly the same code, but it removes SpiderMonkey and just like removes the ability to have a different JavaScript engine other than V8. So now Chrome's rendering engine, Blink, like always uses V8. Safari always uses SpiderMonkey. And probably at this point they're going to start diverging more and more.
So what does that mean for, like, how does, when you say diverging, like, how does that manifest itself in like, how does that affect what kind of like JavaScript you run, or is it like just behind the scenes?
No, it definitely can, right? There are, like, as new features get added to JavaScript or to CSS or to like WebGL, any of the web technology stacks, it was already the case that each browser vendor can sort of decide which features to enable when they compile the browser and produce it. So there was always some difference. But now that the code bases are officially separate, those differences can sort of stack up more and more. So they'll start to. There are standards that kind of keep them from just like going off completely, but when you decide to implement some standard and how exactly you decide to follow it, especially in cases where the standard is ambiguous, as standards sometimes are, those are all points where two separate code bases maintained by two groups of people will kind of spread apart.
So, others asking questions. Would an example of that be like you were showing us the elf loop for
Mm-hmm.
today? Would the example of that be like that's in the thing, maybe these like two code bases like handle it differently, or like one handles it and one's just special enough to handle it?
Yeah, exactly. The most likely case, or the most common case, is one handles it and one doesn't. So it's like you just can't use for of on Safari yet. But I think that's not true. I think you can. And also, eventually, the JavaScript we're writing, we will be running it through a compiler that compiles it to JavaScript. And one of the main wins of that compiler is that it compiles it to JavaScript that works on a really wide array of browsers. So like the for of loop, you don't actually need to write a for of loop. It's nice, but you could just have written like a for loop or a while loop or something. And the transpiler will do that. It'll take pretty JavaScript and make it uglier but more portable JavaScript.
So basically, as a programmer, we are supposed to write out one bunch of code, and the compiler will take care of writing into a different browser, right?
That is the ideal. It sometimes does not happen, as you are going to learn. For the most part, though, that really does work. The cases where it doesn't are usually, in my experience, like this CSS filter or this rule doesn't work on this browser, and it means that this thing, while it's technically degrading gracefully, like the page is running, it just really looks broken, and so you have to like kind of hack around it. Or like the behavior of some functions might be subtly different, and then you sometimes just have to deal with it. And there are libraries that help you deal with it. There's like Modernizer and a whole universe of what are called polyfills, which add new support to old browsers by implementing it in terms of older technologies. A lot of new things you could have written yourself. It's just nice not to have to. Yes.
Is that why, like, in this program, we've been using more ES5 instead of ES6? It's not more browsers.
Honestly, I think that's because we just haven't quite figured out the right mixture of when to teach stuff. I think we should teach ES6 a little bit earlier. Part of why we teach ES5 and ES6 is that, like, obviously code in the wild, code you're going to see in your jobs is going to be a mixture of both. You'll see ES5, you'll see ES6. I think as time goes on, like especially as we move into React, you're definitely going to see a lot more ES6, and we're going to start recommending that you write things that way. So I think that is kind of an artifact of the fact that this curriculum is slightly historical. It's like, that is, it kind of follows a historical path of like early JS and computer science to more modern like React and whatnot.
Because I know there's like some browsers that still don't support ES6.
Right, that's true. But when you compile your code, it'll strip out all the ES6-iness. But it'll do it in a way that is still correct. So like if you use let and it does have to be block scoped, the compiler knows how to do that. Yeah.
If there are two different browsers that are running the same page, do they have these speeds? Is it because of the engine, or is it a combination?
It's because of the rendering engine, which is kind of the like whole core of the browser, everything responsible for going from a URL to a painted page that you can interact with. Sometimes that's a difference in the JavaScript engine. Sometimes it's some other part of the stack. My website. This is why I'm tired tonight or tired today. My website works great on Safari. It works great on every phone. It works great on desktop Safari. On desktop Chrome and desktop Firefox, the scroll is janky as hell. And this is very surprising to me, right? Because I wouldn't have expected Safari to diverge quite so fast. But I think what's happening, to like go off on a tangent, is that Safari, by virtue of being made by Apple, is using core animation to handle CSS filters. And core animation is awesome, and whatever Chrome and Firefox is using is not awesome. But there's a solution. I know you're worried. Any other questions before we move on? Yeah?
Just one last question about the difference between a compiler and its interpreter. A compiler translates, whereas an interpreter can translate if it's not already translated and then execute.
An interpreter, it's a way of thinking about this. An interpreter does what the code is saying. So an interpreter has, like, again with the logo example, an interpreter will have like a model of where the turtle is, how the turtle is facing, and it'll update that model in response to, for each line of code that it reads. A compiler will not have a model of where the turtle currently is. What it will do is it'll output code, maybe machine code, that will cause the memory of the computer when it's run to have a model of where the turtle is, and will cause the turtle to move in whatever way when that program is run. So it's like one step removed. Instead of like just doing the thing, it's making a set of instructions that will cause something to do the thing.
So one's synchronous and one's asynchronous?
Kind of. Yeah, one is, that's an interesting way to think about it. One is like actually doing the work right now. Like one is running it, and the other is preparing it to be run by something else. And the former is an interpreter, which is like actually running it, whereas a compiler is preparing it to be run. Yeah.
But I understand, isn't it like what really the interpreter, what really is one of the compilers, like kind of like fuzzy theoretical question and a lot of things is this sort of in between. Like, so I guess my question is like, so what's the difference between interpreter and just in time?
Right, so just-in-time compilation is compilation. There is a compiler. It's just running when the code is run, when the program is run, rather than at some point before when the code is run. So you do see a lot of these hybrid modes. They're hybrid in the sense that they'll maybe mix some use of an interpreter and some compiled code, or they'll compile it not ahead of time on one person's machine, but right before it's run on millions of people's machines, which when you think about it, sounds really dumb. But that's the world we're living in now. But even those modes, there's like something that's an interpreter and something that's a compiler. They're just maybe being used in a more mixed or fine-grained way within the engine as a whole. So I think those are two like pretty well-defined separate nodes. But in actual engines, you'll see them both used at different times for different reasons. And so it can be hard to say, for example, that JavaScript is a compiled language, or JavaScript is an interpreted language, because it really depends on who's running it. Okay. Let's see. Let's look at some examples of this, and then we'll talk about modules. Let's make some code to compile. Let's see. What is the thing Node shell? I'm gonna call it node.sh, just to confuse everyone. Okay, so let's look at a compiler, like a classic compiler. Let's write a C program and see what happens to that. I'm gonna use Visual Studio Code for this, even though I think it's not meant to write C, but let's find out. Hello.c, and here's my program. You get to watch me try and remember how to write C. So in C, you have to type everything in the sense that you have to provide the type of every variable and every function. So here I'm declaring a function main that returns an int. Main should also take some parameters. Specifically, it's going to take a argc, which is the count of arguments, and an argv, which are the actual arguments. The char star star means it is a array of arrays of characters. It is a pointer to a character, which when you think about a list of strings, that is what a list of strings is. It's just a particularly pedantic way of expressing it. So this is probably the simplest C program. It should just return 0. So let's try running it. So to run a C program, I have to compile it first. And to compile it, I can use the CC program that's built, it's on your computer, you can run it too. I can say compile hello.c and output hello. So now I've got hello right here. Visual Studio Code is refusing to display it because it is weak, so I will use Emacs, a real editor. And here's what it looks like. It's not even that big, you know, you're pathetic. So this program's not that big. It's not very legible either, right? But this is machine code. It obviously isn't actually caret at. Those are just unprintable characters because machine code is not designed to be printable. It's designed to be runnable by the processor. And in fact, if I run it, nothing happens because my main program just returns something. If I want to, I could make this program break my heart by returning 1. And then when I run it, my heart breaks. Why? Any guesses as to why? Yeah, so it crashed. Maybe crashed is stronger. It exited with an error code. So in Unix, and also Windows, I think, actually, when a process exits, it exits with an error code, which is just a number. 0 means everything was fine, nothing was wrong. Any other number means here's the error code that I just failed with. So crashed is accurate. I can return any number here that I want to, and after something has failed, I can go and figure out what the error code was by echoing this weird shell variable. My shell goes and grabs the error code and puts it into it, and I can see it here. If I want to do something more useful, I'm gonna be successful now. I need to, including just like print anything to the screen, I have to include something. stdio is the standard input-output library in C. It is also on your computer. And it gives me the printf function, which I can use to print something. I'm gonna make these one line. I'm gonna say, please compile it and then run it so that we don't have to do that every time. Okay, so now it's printing something, which is great. Maybe it could print something that I tell it to. So like, let's have it print all of the arguments that I give it. That's actually a good idea. So to do a for loop in C, it looks a lot like a for loop in JavaScript. So for int I, not const, but int, is 0, I is not argc plus plus I. So far, so similar, right? Printf argument of I equals, can I do this? Can I do this? Okay, so what you're seeing here are format strings, or this whole thing is a format string. These are like interpolations, which tell printf to put in variables that are going to occur later. That is to grab arguments and stuff them into this string. This is actually something you can do in your console logs, believe it or not. You can just call console log with percent stuff in your string and pass in additional arguments, and it'll interpolate it like this. You might prefer that to doing something like commas or to doing pluses, because in some cases it's easier to read. Okay, so if I run it normally, I will discover that my habit of omitting semicolons does not fly in C. Okay, so if I run it, we see that even though I didn't give it anything at the command line, I'm just going to do this, I actually do get something. I should have a new line after each of these. Printf does not add new lines, unlike console log. So the first argument is the thing that was actually run. And if we write this same program in JavaScript, which I'm now going to do.
How do you type the equals in the line?
Oh, this is a font called Fira code, and you can tell Visual Studio Code. What? Wait, that should be true. Oh, those are the defaults. Yeah, here we go. Editor font ligatures. So if you install Fira code, use that as your font, and then it's basically these two lines. Then you'll get all these fancy like arrows and stuff. Okay, let's do this in JS. Hello, JS. Okay, I think I can. Let's just convert it directly, right? Function main takes argc and argv. And let I 0 return 0. And then I actually have to call this function. In C, main is just like the function that's called. In JavaScript, that's obviously not true, so I can just call main. And I should pass in the count. I don't actually need the count because this is going to be a list, but I should pass in the count of the arguments and the actual arguments, just to keep the parallelism. And that is process.argv, I suppose, .length, and process.argv. I'm going to split this pane just so we see it. So notice all the similarities, right? Like this is a canonical C program, and JS has adopted at least some of the same semantics, right? We have argv, it's on process rather than just being passed in, but we do have it. And we're going to see that we get similar but not the same arguments when run. So let's try running this. I think I'll have some extra new ones, but whatever. Okay, so what are the differences? Let's see. Process.standard.out. But that's better. Nope. Never mind. Never mind. Okay, so let's run hello world and run node hello world. What? Wasn't this working just now? First line. You don't actually have to specify that. What? Wait. Oh. I do, because there's actually a file hello. Thank you. Okay, so what are the differences you notice? Yeah, so I'm getting the full path to the script. I'm also getting the full path to Node as the first argument, which is just something Node does for us. It ensures that the first two things will be the path to Node and the thing that was the script that was specified at the command line. And then, other than that, I get all of the arguments, all of the subsequent arguments, and it's the same. And it's coming in through the same mechanism. Node just has the C code in it somewhere. We can also look at what these two programs compile to. So we looked at the machine code. The machine code is not very legible, obviously, but we can ask for one of those intermediate steps. So let's ask the C compiler to generate assembly code by giving it the -s flag, I think. Yeah, so that gave us hello.s, which I can look at now. Okay, so this is basically machine code, but it's human-readable machine code. It is one step removed. You can do a very simple operation. You run it through an assembler, which is a kind of compiler, but an assembler does not have to do very much in order to get machine code out of it. It's basically taking these, quote, human-readable descriptions for instructions and turning them into the actual bits for the instruction, which is just like a more compact form. And we can kind of walk through what this is doing. You obviously don't have to know what this is doing. It has comments. That's wonderful. But move L is an instruction that moves a long integer from, in this case, some register, like so from some place where to some place where the processor can access it from some place in memory. Calls a function. JE jumps if the last comparison was equal. So if this value is equal to this one, whatever those are. And that's the general trend, right? Like all machine instructions are basically like things you're telling a calculator to do or shuffling one piece of memory to somewhere else. There's a whole bunch of other instructions that do like vector math and this and that, but they're all like very, very low level. Something to notice about the C version is that there aren't that many of them. It's like a pretty short file because it's a pretty short program. Let's look at the JavaScript assembly code. So for that, we can run node hello.js. Oh, crap. And I've forgotten what it is. It's print code. Yep, that's it. Great. That was pretty fast, so let's look at that again. So this is all of the assembly code generated for JavaScript. Actually, that's usually a lot more. I'm impressed. It's still more, though, right? It's still like a pretty good amount more. And maybe for like not surprising reasons, right? JavaScript has a lot more flexibility. It gives us a lot more out of the box. And even though you could, in principle, compile this program down into this, it's very hard to write a compiler that's actually able to do that in the general case. What else did I want to talk about here? Oh yeah, let's now. Okay, first of all, questions about this. If a lot of this is like kind of intimidating, don't worry. You're not. This is the only time anyone is going to like bring up assembly in this program. This is not on the test, I promise. Just wanted to show you a bit of the iceberg that we're all standing on before this. Okay, let's talk about modules in Node, and then we'll, one last time, look at the assembly dump of a Node program with some modules, because that is hilarious. Okay, so we've been writing all of our code in files that we just reference with script tags. That obviously works if you have an HTML document to reference all of your files from. It has some drawbacks even in that case. What are some of them?
Depending on what order you call them in HTML, they might not be able to read each other.
Yeah, exactly. Like if what is it, game needs board, if game occurs before board, then it breaks for reasons that are not obvious looking at either game or board, right? You have to know that this ordering is important, and it's an ordering defined in some completely separate file that it's really not obvious. It like contains the document. It probably shouldn't like make the code break or not break. So Node has a module system. And also it doesn't have an HTML file, so it better have a module system that lets us require code from one file. It lets us require a module into our program. So it lets us require a different file into the current file we're working in. The way it works is this. If you have a file and you want to export something from it, you put stuff you want to export onto module.exports. So you can either say like module.exports equals some object that you want to export, or some function that you want to export. It can be any JavaScript value. Or you can just say exports dot, I don't know, foo equals 10. Exports starts off being the same thing as module.exports. And then on the other side, you require a file in order to get whatever that file exported. So you get whatever thing, whatever JavaScript object that file assigned to module.export when it was first run. Yeah?
Oh, I think you're going to answer my question. What's the required?
Yeah. So it finds a file, it runs it, and it returns, really, rather than importing, it returns that file's exports. So the process of finding a file means if you give it a relative path, so if you're like, or an absolute path, so if you're like require ./hello.js, then it'll go and look for hello.js in the current directory. If you just say require foobar, like just that string, or foobar/x, something that does not start with either a dot or a slash, then it'll go and look for it as a module. So it'll first look for node modules in the current directory. If it doesn't find it there, it'll look for node modules in one directory up. And it just keeps searching until it finds a node modules directory that contains what you imported. If it doesn't find that, when it's looked all the way up to the top of the file system, it fails.
And a node module is just any file that you put this module.export thing in.
Yeah, exactly. So a node module in the sense of like the node modules folder is just, it's just a JavaScript file, or it's just a folder inside of node modules. And then a module in general is just, any JavaScript file. We'll look at the example. It'll be a bit clearer. So this resolution order is what it's called, is defined by Node. And it was defined by Node in order to make it easy for package managers to, basically to make it easy for Node to support a wide variety of package managers, right? The only thing you have to do to install a module such that Node can find it is put it in some folder called Node modules that's somewhere like at or above the folder that it's being required from. And that's what npm does. npm is a Node package manager, and you can npm install one of the huge number of packages, and it goes and grabs it from the npm repository and puts it into a Node modules folder on your computer. Specifically, it puts it into one for the current project. And the current project is defined by the closest package JSON to you. So a package.json file just says, hey, this is a JavaScript package. It has a few fields that are required. I'm actually not sure any of the fields are required formally, but it has it usually has a name, it has a version, it has an author, and this is all it takes to make something a JavaScript package. It's just like a file describing it, and then npm will know to put a Node modules folder next to the package JSON. So this is particularly good for collaboration within your team and sharing within Node. So let's just create a demo project because I think it's easier to think about that way. Okay, we're done with assembly for now. Let's focus on JavaScript. Okay, what should I do in order to here? Okay, let's say that this is a very synthetic example, but let's say I wanted to print all arguments. And I want to like make that. Oh, actually, let's do this. I'll make this thing where I loop over a array and print each part of it. I'll make that a separate function. So we'll say like function print array that's going to take the array. And this is obviously kind of a dumb function, right? But example, it's an example. And we'll give it a label, which starts as arg. This will be label I array of I, and this will be array.length. So now I can just say print array of arg. JavaScript. No semicolons here. Okay, so if I run this, so I'll do this over here. Hello. Okay, still works, great. But now I have two functions in this file, and that's just too many. I need to move this function to its own file. So let's create a file for it. It doesn't have to be called print array. In fact, let's call it like util.js because every project has a util.js. Why not this one? And we're going to move this function into it. So I can say, okay, so now I've separated my code. That's great. And in order to export it, I'm going to say module.exports print array. And in here, I can say, I'll do it at the top, is traditionally where we like to require things. I can say const print array equals require util. I can say .js, I don't have to. If I don't, Node automatically looks for a few specified extensions. So it'll look for .js, it'll also look for .json, it'll also look for a .node file, which is usually for like a binary extension. And then when we use Webpack later, we'll also be able to use .jsx as a file extension. Yeah. So if I just did this, it'll look for a module of that name. Or, yeah, it'll look for a module of that name. Meaning, so if I did this, it would look for node modules util, and then if it didn't find that, it would be like, okay, what about ... / node modules util? Okay, what about ... / node modules util? And it'll just keep going until it gets to / node modules, like the root of the file system. And if it doesn't, and then it'll fail. Okay.
And NPM is what? Change things to do that?
No, so NPM takes advantage of this, but NPM did not exist when this resolution order was created. Node just decided that's how it would look for modules in order so that it could support package managers easily. And it can. Node NPM is like very popular, and it's like quite easy. This is like the easiest package manager to use that I've ever used of any programming language, which has some drawbacks, namely when we npm install something. Here, well, I'll get to the drawbacks when we get to actually installing something.
But the node modules are like the files. It's just going back up to the...
Yeah, it's just in the file system. Yep, and we'll look at that.
So
Yeah.
So there will be a node underscore module folder being created?
Yes, there will be a node modules folder created, not now, but when we install something from npm. When we install the first thing from npm, it'll be like, I should create a node modules folder. You can also create a node modules folder. You don't have to like wait for npm to do it. But typically, we let npm manage that folder, and we don't put our own code into it because it's convenient to be able to delete it, to just say like, okay, something's wrong with my dependencies, I don't know exactly what's happened, I'm just going to delete my node modules folder and recreate it. And like npm install again to recreate it.
So like under which folders is node underscore modules usually created?
Sorry, say again? We'll look at node modules in a second. Actually, let's just look at requiring first. Okay, so print array is going to require util. Util exports this print array function, and so when we run this, we find out that printf isn't defined because I'm using it here, right? I forgot about that. Let's just change it to console log. Oops. But that means it worked, right? That means we got into that file. Okay, here we go, and it's working. And we can actually kind of see what's going on if, as far as Node is concerned. If we look, let's do this in the REPL. Where is this stuff? So yeah, require.cache actually contains a cache of everything that's been imported. Oh, yeah, wait, so let's justify why we should care about that. Let's say that I log something here. I am in print array. Okay, and let's say that I do this. Okay, so if I just run this program, we can see that what happens when I require is that util gets run, and then we look at what module exports is, and it becomes this value. It becomes the return value of require. What happens if I do it again, do you think? In fact, let's do it like, you can do it anywhere, so like let's do it in here. Be crazy.
You can run the whole file so you can get a console log, you get
Wait, sorry, say again?
It's probably completely wrong, but it doesn't run the whole file again, so you would just get the function, but you would get the console log.
You do get the function. I wonder if there's some way we can figure out if it actually runs it again. You're correct, although it doesn't run any of it again. So we still just see one print statement. And the reason is, once you've required a file, the return value of require is cached. So we can look at this by requiring util, and you actually don't have to use the return value of require. Great. So we see that it got to this print statement, it returned print array, and now if we look at require, we'll see that require.cache has some stuff in it. Specifically, it's got require.cache is an object whose keys are absolute file names, in this case the absolute file name to the absolute path to util.js, and whose values are these module objects, which are just, this is all like pure JavaScript code. You can go like look at how it's implemented in Node. But it's just a module is just a class that Node has written that handles the intricacies of its module system. In particular, a module knows who required it first, and in this case, it's the REPL. So this is a kind of weird module. It knows what was exported, and here are all the paths that this module will search when you try and require something without specifying the path. So first it'll look in Node modules, and then 1 up in Node modules, and then 2 up, all the way to the root of the file system. And we can keep going, right? If this imported something, like maybe let's put printf in its own. That's actually nice, right? Const printf equals require printf, and then I'll put printf in its own JavaScript file, and just export console log. So now I can require printf. I have to do the /. Okay. So now my program still works, I think. Let's verify that. Hello.js. Yep. And then if I require util, and I then look at the require cache, I'll see that my I've got util in here, and then it has one child, which we could dig into it, but I promise you it's this. It's printf, which has no children, but its parent is util, and so on and so on. So Node sort of maintains this notion of a tree of who imported them. The child, so require cache doesn't have a child, but each module in the require cache has a child. So require cache of, let's look at this one at util.js. .children is printf. So this is here. Printf is a child of util because util requires printf. Is that right? Yeah. And util is a child of hello because hello requires util.
So whoever requires it is the parent. Whoever, yeah.
Whoever requires it first.
Is the parent.
Yeah.
Okay.
And then the first one gets to be the parent. Subsequent modules that reference it are not Yeah.
Branches or?
No, they're just not represented in this tree.
Oh.
How come you have to assign like required to constant or variable or whatever? Like, it just putting required doesn't like mean that everything that all the functions that were in require are now available.
No, you have to, because require is actually just a JavaScript function. And a JavaScript function can't just put stuff into the namespace of its caller. That's just like not a JavaScript operation. So there's just like no mechanism to do that, except of course that there is another way of importing and exporting modules that we'll see later that does let you say, just grab all the names from this and put them into me.
So that would be like, say there was like some function called hello in util, you could access it by going then print array.hello in the other one.
No. So let's write that though. Let's say printf hello world. So this function I can't access at all. There's actually, I mean, I can access it inside util, but I can't access it here. If I try and do that, and I'm like print array.hello, then it's going to tell me that print array.hello is not a function because I didn't export it.
I guess I was meaning if you'd done it in a whole object, like exports within the whole page within like an object that was the export.
Yeah, so I could do this. I could export, instead of just exporting print array, I could export print array and hello. This syntax, by the way, it's like a short form for object literals. So it's like I said, print array colon print array and hello colon hello. But who wants to do that, right? And JavaScript now lets us not do that if the key and the value have the same name, exactly the same name. You can omit them, or you can just do one thing. But if I do this, I now have a different problem, which we'll get to in a second because I see hands. Yeah.
I think maybe I missed something, but I'm trying to figure out why we would do a module export with a require in another file as opposed to just writing all this code in one file. What are we like? Well, am I just missing what the purpose of module exports require is?
No. So for this example, you're right. This is not a case where we need to break this into multiple files. It would be easier to understand in just one file. But at some point, that won't be the case anymore. At some point, you'll have, like, maybe it's 200, maybe it's 1,000, maybe it's 2,000, maybe it's 10,000. If you have 10,000 lines of code in one file, that file is going to get really hard to move around in. And if you have 20,000, it's like you're working on a whole book in a single file, which is a way some people write books, I think, but I find it hard. And it's generally easier to have some kind of organizational system where you can break your code into chunks. And so
The module exports and require is just helping us to communicate between those different files so that we can then operate our code or whatever.
Yep.
Okay.
Yeah, exactly. And also, it helps with reuse. So if I write all of the code for my program in one file, and I want to reuse some chunk of it in another project, how do I do that? I would have to like copy it out and paste it, but then now say I find a bug in that piece of code and I fix it in one place. Now I have to go track it down everywhere and fix it there. And this basically isn't very scalable. Like it'll quickly devolve. Yeah.
How did you make the game file and the board file communicate? Because we had functions that we used in there that were written in a different file. Did they just communicate through the HTML records?
Yeah, exactly. Those were just those were just in the index.js or index.html, which is here. So because we had not yet introduced require and all that, we just do it like this. We just have two script tags, and they're important. They're both in the page. And this is actually a little different, right? Because, for example, game.js never says, wait, where is board? Yeah, so we're calling new board here. Well, we never say like import board or use board or require it or anything. And likewise, we never say export this. It just happens to be the case that because this is declared at like the top of the file, it's like not inside a function, it's global. Within the browser, if you just declare something hanging out there, it's going to be accessible everywhere. It's even accessible in the terminal, or in the DevTools console. I could type new board and play with it inside the console. So that's kind of nice. It's kind of nice that I can access it in the console, but it's sort of a major scalability problem if every name of every function I declare at the top level of any file ends up on the window. Because why? What's that? Traffic. Like, what sort of traffic?
Everything ends up on the window.
Yeah, everything ends up on the window, which everything has to end up somewhere, so why not the window? But what if in this board I was like, you know, the board should have life. I'm gonna give it life. That's actually a bad example, but because I think it won't break anything.
Because you would have to constantly load all the files in order to like move around with them to be executed, right? So,
It's
so it gets kind of clogged up with like the request of what it needs to do, so it'll slow it down.
It's not really a speed thing so much as a, what if in a different, okay, so this project just has one board and one game and one life, fine. But what if, board is a pretty common English word. You might imagine having multiple boards. Like, I might, in a project with more complexity, have another thing, or I might load a module that has another thing that it wants to call a board, right?
So it'd be like a conflict of the variables or
Yeah, now when I am in game.js and I say board, new board, which one of those two things do I mean? And the answer will be one of them, but it'll only ever be one of them everywhere, which means it'll be wrong like half the time. Because presumably somewhere else I'm trying to use that board I declared previously, but I'm getting this other board.
it's like if someone else came after and started working on your code and didn't know what you call things and they start changing things around, they could ultimately just break everything.
Or even if I just import a library, and that library, like jQuery is a very popular library, and it defines $sign globally. Maybe someone else wanted to do that. Like, maybe a different library also thinks I am the clever little tiny function name library, and so I'm going to define $sign. Now, when you type $sign, which one do you mean? You'll get one of them, but it's totally unclear which one you should get. And what's more, if you actually want to use both those libraries, you have to. How do you do it? It's like there's sometimes no way, or you have to like really hack their source. And so with Node, every module has its own sort of global namespace. There's actually a hidden function that you can't see wrapping all of this. And so when I declare hello here, it's not global. It's like local to this module.
It no longer lives on the window.
It no longer lives on the window or in Node on the global object, which is the equivalent of the window.
Are there any issues with that at all? Or any
Not really. You can put things, if you want things global, I can say global hello equals hello. And then do it very explicitly. Yeah?
So, on this, in this file, you are printing I am in print array up top before print array, and then you're assigning the print array to module exports.
should say that, yeah. But yeah.
So why are you getting that statement when you run hello.js if it hasn't been assigned to module.exports?
Good question, because this statement prints something as a side effect. Right, so as a side effect of executing this line of code, something gets printed to the console. As a side effect of executing this line of code, a function is declared within this module, which doesn't have any visible effect. I could, for example, call this function here, and then when I run hello.js, I'm going to remove that file 1 second. When I run hello, why am I seeing it 3 times? I did a lot, didn't I? Oh, I was kind of mid something here. Let's go back to what we had. Print array. Sorry. So many questions. Okay. Print array.hello is not a function. Let's not do that right now. Okay, so hello world. Let's be like, oh, give me a sentence to type. Okay, oh, I feel dirty. Okay. So now it's getting called, right? Because I'm like actually calling it, and this statement has a side effect that's causing it to be printed. But just having the function here isn't going to do that. Just the kind of, you're looking very skeptical about this.
I just don't understand it. With the module, you're assigning module exports, you're assigning print array to the module export.
Yeah.
So everything that's not print array, why does everything that's not print array get run when you run hello.js?
Oh, because that's what require does. That's like how require works, is it runs this whole file, and then it looks at whatever was in, whatever is in module.exports after the file is run. In fact, what happens is require, okay, so when you require something, Node finds the file, it grabs the text of the file, and then it wraps it, like literally you can go and find the code in the Node repository that it wraps it in a function that looks like this. It's like require module dir name, file name. I think that's it. So it wraps it in this function expression and then immediately passes in some stuff. So module name, file name, probably without the underscores. And then afterwards, so this will be, and then afterwards, it's like, okay, set module, module object dot exports equals, actually, I don't even think, I think this literally is the module export. I don't think it's doing anything afterwards, right? Because we looked at, this might just break, yeah, bad example. How about printf? Have I screwed up printf? No, great. Yeah, module export. So that probably means that if I print module ID, I'll see an ID when I require this. Yeah, totally. Okay, great. So this module in module.exports actually is this module object that's sitting in the require cache. That may not be too exciting to you. But what it means is that the things you are exporting from your module are basically getting exported as a side effect of running this function. It's not the case that Node somehow knows to go in and look only at print array. It actually has to run the whole thing, and then it's able to, and then actually your script, this file, must have done as a side effect whatever it needs to do in order to set up exports with what it wants to export.
Can you assign module.exports to any function that's in that util file?
You can assign module.exports to anything you want. You can make it.
Is there a way of capturing the whole page?
Hmm.
You can put it inside of the whole page inside an object to make it use that object.
What would it mean to capture the whole thing? Like every function defined in it? But what about these? Do they not count? So no, because it's not like really clear
So
what.
you have to write out, say you had a page of 80 functions, you want to capture them all, you'd have to write the name of each one out.
Yeah, I mean you can also do you can do these differently, right? You can say exports.hello equals that, or yeah, it actually isn't, I think, that bad. I actually often like doing it at the top. I don't think it's that bad to have to say like, okay, I want to export both these things, so here I am. Here's what this file exports. You do have to be explicit about it though. Yeah.
So I guess this is just like a really general conceptual question. Like, why would you build a file and write a function that you didn't need? Like, why would you write a function that you didn't need to export?
Oh, well, you might need it, but you might not need to export it. Like, maybe you want to use it in this file, but not out of this file.
Oh, like if it's a callback or something.
Yeah, or it's just like, it's a helpful function for you in this file, but it's not something that callers need. Maybe even it's something that you don't really want them to have access to. It's like, it can't be like a security thing, but it could be like if you call this function, you can really screw things up. And so there's no need to make the interface to this module like more dangerous by exporting things that you have no reason to call, right? You actually want to export as few things as you can while maintaining the functionality that you want.
Okay, so another general question, but like
Go for it.
with the module, like the things that you're passing up and exporting and requiring, and the documents you're requiring. So it's when a user is trying to perform an action, it's those functions that they need to have access to, or those dependencies. Like, I guess I'm just like confused as to like then what do you need to pass up?
What do you need to export?
Yeah, like what do you need to export?
Yeah, you need to export whatever you want callers, whatever you want like users of this module to be able to call.
Okay.
So, let's think of an example here. I'm sort of having trouble in this like very synthetic program, which it doesn't do anything, like come up with something.
It's like our toggle function that we needed in game. If they used toggle in game, if it wasn't scripted, we would have had to do this, right? If it wasn't scripted in the HTML.
Yeah.
That toggle function, because we needed it in the game function.
Yeah.
It was only on the board. Okay.
Wait, but board was. You could have used it, right?
Well, board
maybe
was scripted first in the HTML, and then game came after it. But we used the toggle function was actually in the game. The toggle function that was created on the board function was created. Well, we used it in the game file.
Right.
So in order to.
So that's something you would export.
Yeah, that's
Yeah.
something we would export if we didn't script it into the HTML.
Yeah, and I'm just trying to think about something that you wouldn't export, or like a good example for that.
Like
Well,
the
rules
function-
in the game, Conway. Like,
Oh yeah,
so
Conway.
you can't mess with the rules, you can't screw up the way to get your functions, but you can toggle cells and things like that.
Yeah, I guess you actually don't need to export Conway there ever, right? You can just like not specify it. You also might export Conway in sort of a game of life library because you might want to call tick with, you might want to pick which rule set. Conway is the default though, so yeah, you're right. You don't have to call it. You don't have to export it in that case.
Okay, so like something that the user is interacting with, like toggle,
but like something that we were using as a helper function to find living relatives or what, I forget what it's called, but like something that was
Yeah.
just there for the for functionality, that sort of thing.
Right.
Yeah, got it.
And Game of Life is like sort of, that function in Game of Life is maybe not the best example just because all of those are methods on a class and you can't choose to export some but not all the methods of the class. What's that? You cannot. You can do something else to have sort of private methods, but we're doing enough mind-blowing things just now. But yeah, for the most part, because the reason is if you're exporting a class, what you're really doing is exporting the constructor. The constructor holds onto the prototype. The prototype just has everything on it. There's not really a way to be like, just export half this object. You get all the object, or you get none of the object.
Okay.
Yeah.
So while we're running this required function, like we were going through all these modules, it's adding all of this in this required object, right?
Required cache.
Cache. When does it get cleared out? Or does
Never.
it get cleared out? Or so it doesn't jam up like with all of this?
I mean, it's possible, but it's always bounded in how big it can grow because you can only require things that are there on the file system. So you could just have to require so much stuff that your program is too big to fit in memory, but that kind of just means your program is too big. It's not the case that it's going to be perpetually growing, which is where we really get into trouble. All of the source code in even a big project is probably not actually that much space for a computer to deal with.
Are we exporting only function?
No, we actually are just about to. If you want to just export one function from a file, then yeah, you can just export that function. If you want to export two functions, though, then you should probably export an object.
Anything else I can export?
Yeah, you can export anything. You can export anything that you can use as a value in JavaScript, which is literally anything. There's no, because again, this is all just kind of sugar around setting some values on the module object. So it can be literally anything you want. It can be a typed array. It can be a weird buffer object in the browser. Oh, though you can't use require in the browser. It can be another module. It can say module.export equals require something. That's fine. In this case, we've actually just, so we're saying we want to export hello and print array, which means that we basically have to export an object. I guess we could use an array, but don't use an array, that's terrible. You want them to be named. And if I do that, so now if I run node hello, it's going to tell me that print array is not a function. What did I do wrong?
Print array is not a function?
Yeah, so here's the if I shrink this one step, is it still visible? Okay. Cool. Oh yeah. Yeah, what am I exporting instead?
Oh, you're exporting the
Oh.
Yeah. Yeah.
So you want to use with object on?
Yeah, so this is a lie, right? And in fact, I can console log print array to get a sense of, it's like I think print array equals, and what does it equal? This object that contains print array and hello, which I guess isn't surprising because that's what I told it to export over here. So what I actually want to do probably is say like const util equals require util. And then in here I can say util.printarray.
general scenario in a normal practice, do you export more like modules only, or what is the generally way you use modules only, right?
You mean objects like this?
Yes.
It's a pretty mixed bag, actually, because sometimes you'll have a file, like it's very likely that a file named util.js will export an object with a bunch of functions in it. That's usually just util is a grab bag of functions. But it's also very common to export a single function, usually a constructor function, or often a constructor function. When we learn React, we'll be exporting components an awful lot, and components are just, they're just classes, so they're just constructor functions. So I'd say those are the most common things. You'll also sometimes see exporting just an object with some config, right? So username, email, password, var. This is a bad example. You wouldn't want to store your Gmail password like this, but that's. But like when we work with external APIs and start having to deal with like, oh, the key I need to send to Google so I can use their service, got to put it somewhere. Usually you put it in a file that you can require. Oh yeah, one last thing. So this is one way of requiring a module. Another way, or of requiring requiring a module that returns an object and then calling a function that's in that object. We could also just assign print array here, right? So I could say print array equals util.printarray. And then I don't have to preface it with util, which is kind of nice, or can be nice. And I could even use destructuring so that transform was this. I said, put curly brackets around this, and then get rid of it on the right-hand side. These two lines are equivalent. And if I'm going to do that, then I could just do it to begin with and say const print array equals require util. And this is called destructuring assignment. It basically says, okay, these are pretend that these are the idea of an object with this field. Reach into the object on the right-hand side and pull out the field named print array and make it a variable. You can go completely crazy with destructuring if you're me.
And then you have to use that with the curly braces on it in the code, or you can
No.
just say print array?
No, this after this has been done, it's just print array. It's just like a normal. These are completely equivalent. Yeah. Oh, what did I do? Okay.
So in that case, how we will use hello function?
Oh, good question. We can also just say and hello.
So we'll need another.
Let's call this goodbye. Oh, and this should be called bye. Yeah.
I'm just wondering, how do you keep track of what requires what and where to put it? And kind of like, because I'm like sort of following, you know, like the benefits of having it done this way, but you don't want to like.
No, I know exactly what you mean.
How do you keep track of it, and how do you know? Like, do you leave notes for yourself at some point? Like, this is reference, this is reference.
Good question. So, no, that is the fundamental problem of large software projects.
So you are just leaving notes.
Yeah, you leave notes, you adopt conventions. There are editor tools that can kind of help you. So at a minimum, like when I can command click on this and it takes me to where it's defined. I can also command click on any function and it'll take me there. So your editor kind of knows. There are even, I think there are even modes that show you like more of an overview of like this references this. But a lot of it is just sort of learning how to, one, track things down. So like do all that clicking and follow like what a given path does, and then having some kind of convention in your code base, in your code base as to like what is probably going to require what.
Like you would kind of, as you were working on some kind of project, you would break down your code into like, oh, this responds to like this part, and then you might be possibly using this other file that does this other thing, but could be using parts of the code from this file, right? Is that kind of?
Yeah, so you'll usually sort of segment your application into layers or into like different sort of smaller applications. So like over here we have the what's a good example of this? Like if you had sort of Facebook's like way too big an example. You have like Twitter. I don't know why I thought that's smaller. So Twitter, it's like you have the feed. The feed is like one sort of submodule. And you can sort of imagine that the feed is going to have like the view of the feed, which like displays stuff on the page, and then it has some layer that lets it talk to the server that has that manages having this list of tweets, and then under that there will be like a layer that talks to the database that stores all the tweets, and you kind of get used to how, like, what pieces to expect and how the pieces are probably going to talk to each other. But yeah, when you start working on a new project, or rather when you come into a new code base, especially a large code base that you don't know, it can be challenging to figure out like where everything is and what requires what.
Because I guess until now we're just only been working on like one-page things or just writing little functions.
Yeah.
So we haven't really experienced having to like reference them
Yeah.
anywhere or have them I don't know why that big turn into that, but
No, so it's like a very good question, and it is like the problem of software engineering basically, is how to break your thing into parts such that anyone can understand what the parts are and how they talk to each other and like what the dependencies are. And sometimes it's obvious, sometimes you have a nice code base. Usually every code base has parts where people are like, we just don't go there, we just don't touch that because we're not sure what depends on it, and if someone tried to change it 2 months ago and it broke everything in a way that we didn't detect for a week, so we're just leaving it alone. I shouldn't say every code base has those, but there's usually one. There's usually something somewhere. Yeah.
I'm sorry, but I'm still a little confused. If we want to export an external library, which we have not written, then also we have to do this only, or there's something different?
We should talk about external libraries. That is a good point. Okay. Yeah, because we've talked about like require a bunch, but not yet node modules. I saw one more hand before I jump to a new topic. Sorry, design patterns? Yeah. Yeah, I mean, having design patterns really helps, and like knowing design patterns helps in terms of figuring out where to put things, and then if you come to a code base that you have not seen before, figuring out where people might have put things, because they're probably following some design pattern, maybe. Yeah. For sure. So like a common design pattern is like model view controller, or at least like model view like having a model view breakdown which we had in Game of Life, right? We had the model, which is the board that sort of manages the idea of the game or the idea of whatever thing it is you're trying to display, and then you have the view, which handles displaying it and dealing with user interactions. And so then at least you can be like, okay, if I want to add a feature, I want to like add a button to the page, I can start with the view, and then I'll have to add whatever that button does, I should put it in the model, and then the view is going to talk to the model. So you kind of have an idea of where things can start to go. Yeah?
So would it be ways to impose using that type of implicit logic for how they categorize it, or not? Would there be main documentation, part of the work on, like, here's what's in this, and we'll also how to account for it, or you just kind of...
That is absolutely sometimes the case. It's that documentation is also usually a little bit out of date because someone, especially the like very pretty diagram, because it's like easier to add some new code than it is to update that very pretty diagram. So unfortunately the documentation often lags in engineering projects. Yeah, that's awesome. You should definitely do that. And I will come to you during Capstone and be like, so how's that documentation going? And that's the problem, right? Is like people want to ship the product, and the documentation that makes it easy for other engineers to come in and work on it, and easy for yourself to come and look at it later, is however nice it is to have, it's not the product, and it does take time. And so, like, which thing wins? Often, like, shipping over documenting what you've done. And so, something we talk about a lot is having like, self-documenting code, which is often kind of a lie, right? Like, this code documents itself. I should add that comment to, to the most obscure function I've ever written or something. But you can write code with like a theme to it, right? If I'm trying to think of like a good metaphor. We'll see it. You'll see it as we build more and more complex projects. But if you name something Eagle and you name something else Haystack, you have a sense that probably a search is going on. If you like name something like blah model, then you will probably go off and look for a blah view if you want to figure out how that thing is displayed and change it. So if you have these patterns and these themes, then it can help you orient yourself, even if you don't have a document that's like, here's how everything works.
Is that kind of like the function composition, where you write it in a way that should be easy to understand if someone is looking at it, when it comes to like naming things the way that it's descriptive?
Yeah, that's the ideal, right? Is that like I can like look at your function and get a sense of what it does, just even from the names and sort of how they're arranged. And similarly, it's nice when I can look at a code base and have an idea of what's going on just by looking at the names and like maybe skimming some of the files. Rarely is that, it's never totally the case, but that's the thing to strive for, I think. Okay. Other questions about this before I wanna load an external module real fast. Okay, so let's first, before we go and actually install an NPM, let's look at how Node requires like external modules or things that are in the Node modules folder. So to see that, let's create the Node modules folder. Okay, it'll be empty right now. And let's move util.js into it. I actually wonder if that works. To Node modules. So now when I require util, I don't have to say // I can just say util. And this is not going to work because I gave it a bad name, but let's watch it fail. Print array is not a function. Okay. So what did I get when I imported util? Let's actually break this out again. We'll say util equals that. We'll go ahead and say by. And let's also log the util modules. I think this is util. Okay. So that's like a lot, right? That's not what I exported. What happened is that util is actually the name of a built-in Node module. That kind of makes sense when you think about it. And whenever you require just the name of a built-in Node module, that's what you get. There's no way you can change it. That's just the module you're going to be getting. So let's call this, instead of util, let's call it Asynchrony. And so now I think I can just require Asynchrony. I might have to put it in a folder, but I think I don't. Cannot find module printf. Right, util needs printf. Right, we required printf. So already we're seeing the challenges we can face when we try and extract something into a separate project. I'm just going to punt on this one, because printf is a pretty stupid module to begin with. Okay, so now it's working again. And so what happens is, when I require Asynchrony, Node first looks in Node modules in this directory for Asynchrony, and it finds it, and that's the module I get. Okay, now let's put it back because I'm about to install a bunch more Node modules, and I kind of don't want them getting stepped on. So let's move Node Asynchrony to util.js. Let's put this back. If I run this, it should still work. Great. And now I'm going to do two things. I'm going to initialize a package in this directory with npm init. And then I'm going to install something to do something pretty. I don't know what. We'll think of a module. So the first thing is npm init. All this does is it creates a package.json file in the current directory. So the package name is playing with Node modules. This can be anything. It is the name that this will get published as if you run npm publish, but you can always change it. You can always change it in package.json. Version 1, sure. Description, doesn't matter. Entry point, hello, fine. You don't have to enter any of this. Yeah, great. Okay, so now I have another file here. It's package.json, and it has all the information, or the complete lack of information that I just provided. I could give it a description. I could say this is by me. If I actually wanted to publish this module, I would definitely do those things. But I'm not going to publish this module. Instead, I'm going to install some stuff. And the thing I'm going to install, let's install Chalk. So if I just do npm install Chalk, it'll install it into Node modules, but not list it as a dependency here. That's not so great. So in general, when we install an external module, we want to remember that we depend on it, so that when someone else pulls down this project, when someone else gets this code from GitHub, they can run npm install with no arguments, which will install everything in dependencies. So this is how we transport dependencies alongside of our project. It's not exactly alongside of it, but it's, as we'll see, this will track exactly what version of Chalk we're going to depend on, and it guarantees that you and your collaborators will both be using, you'll both have all of the libraries you need to make this project work.
Version get updated, or if it's that particular dependency, that new version, we have to come on
Package JSON and change it. Yep. Yeah, if you want to use the new version. exactly. So I'm going to say install save chalk. And it's installed chalk. If we look, we now have a dependency on chalk. If we look in node modules, it installed more than chalk, in fact, because chalk, of course, has some dependencies of its own. Where are they? Here they are. And some of these have dependencies, and so on. So with one command, you can really get a lot of the npm repo. And now we can use it. So having installed it, let's just use it in here and say chalk equals require chalk. And I've kind of forgotten how this works, but it's like chalk dot green. Oh yeah, there we go. And now it's green. Yep, that's all it does. But if you want to print things in color on the terminal, your options are install chalk, install something else that does it, or go figure out how to do it yourself. This is like kind of it's not, you know, super hard, but it's like kind of non-trivial.
So I think maybe those modules are specifically for that will be running in the terminal, which is your shell.
Wait, sorry, what is?
The node becomes kind of like your shell. This one, or?
Wait.
So like all these modules,
Mhm.
they communicate between the files, right?
Yeah.
And if you install it in your project, it just makes your node pretty.
Well, so this one, all they ever do is give you things that you can require. So chalk gave me itself. So I can require, so installing chalk means that I can require it, which means that I can call functions on it, which in the case of chalk, it just makes my print output pretty.
What about some other ones that are like actually useful? Not that it's
Yeah.
useful.
How about okay? There's color functions. So like RGB to here. Let's just write another program that's like. Okay, sometimes you have an RGB color and you want to turn it into HSV, right? That's something. Do we know what that is? Do we want a different use case?
Like a reverse.
There's like different ways of representing color. There's hue, saturation, value, and there's red, green, blue. Hue, saturation, value is nice because, for example, it makes it easy to represent shifting the hue. You can just like add 50 degrees to the hue, and that's going to change like red to I don't know, to like a bluer shade. And if you do that to maybe this is a bad example.
Closer to like how you deal with color as a person rather than a screen. Like a screen is made up of a whole bunch of RGB pixels, but when we figure out putting colors together, we don't do it with red, green, and blue.
Right.
It's a little closer like using paint than like.
Let's pick a different example. Let's pick Axios, which lets us make HTTP requests, and we'll like make a little browser. Well, not a browser. We'll make like curl. We'll make something that can go and fetch a URL. Did I say that question?
I do a question, but it's like not quite related to this.
Okay. Okay.
What's the initial command to set up the npm? Like not the install save, not to add it to the dependencies, but to just make that initial file.
Yeah, it was npm init.
And you would do that when you're in the file that you want.
Yeah, so you create a directory. The usual flow is you create a directory with the name of the package that you want, and you npm init there. The real flow is you have a few. I have a few little skeleton repositories that they have like a very small package JSON. They have a README, and they have a couple of other things, and I just clone those repositories. So I I call one of them scratch, as in let's start from. And then I have another one that has like a more intricate build process in it for like doing front end stuff. And most people have like some kind of go-to like way to just start a project. You too will have this. Okay, so let's do like get URL. That sort of seems obviously useful, right? Like if we can just like get the content of some URL that we accept at the command line. So to do that, I'm going to use the Axios library. You don't actually have to use a library to do this, incidentally. You can do it with built-in modules in Node. It's less nice. It's just like a less friendly interface.
Does Node just have a list of those libraries with descriptions of what they do? Or
Yeah.
and people like contribute things to it all the time?
So there are two things here.
You could come out
Am I
with
not
like-
streaming? No, I am streaming. Is it not working? Okay, whatever. Is anyone watching the stream? No? Okay, great. That's oh, it's live. Okay, great. I had a moment of fear. So, yeah, so Node, if you Google Node API, you'll find the Node.js API. So all of these on the left are built-in modules. Oh, man. So there's stuff to deal with the terminal, stuff to deal with the network. There's V8, which gives you just direct access to V8 things. Buffers, async. Whoa, interesting. Huh. Okay, yeah, they're adding new ones all the time. I have not seen all of this. And then if you're curious about, so those are the ones that are built into Node. You don't have to install them with NPM. There's also npm.js, which has like just bajillion packages. So if I want to look for packages that are about, I don't know, math. Oh, wow. Here, oh, that's a lot smaller than I expected, actually. But I bet if I look for React packages, there will be like 45,200. Wait, how is it? Oh, I see. That's the page number, not the page. Okay, so maybe there was a lot of math packages.
It was like 3,000.
Okay.
So you would have to install each one depending on what project you were working on if you wanted to use that package.
Yeah, so you install like the package that does the thing you want, and then it'll also have a bunch of dependencies that you don't have to worry about. Like npm will install those when you install the package. So yeah, usually if I want to do something, I'm like, say I want to do what's a good example? Color complement calculation JS npm. Color. That was obvious. Also, complementary colors. What if I wanted all emoji in an npm? Node emoji. Great.
So that is what you would put on your dependency.
Yeah, so I would say
Like,
npm
install -- save.
node emoji. Yeah, and most of them even say like exactly what to do here.
Right.
Yeah.
In general, how many like exports package now? So I guess we're asking this, but we have the example where if like one of our files we exported 2 functions, then when we required it, we had to account for the fact that we really returned 2 functions. Does it vary widely across whether you're using it? Or is it like standard only one, so you don't run into that problem? Oh, getting 2 functions back. You're getting the return.
It does vary. It's more common to have fewer I think. It's more common, I think the most common case is a module will export a function, like a function. Sometimes that function will have other functions on it as properties, which is something you can do. You can just say like, you know, foo.bar equals this other function. And sometimes it'll export an object with a bunch of functions, but that's a little bit less common. The general trend in the JavaScript ecosystem is towards more small packages that individually do less. So you'll actually see, like, sorry, I'm in like color space right now, but if I look for like an NPM that does RGB to HSV, there's literally an NPM that just does that. The only thing this entire package does is it provides a HSV function that takes RGB and returns HSV. There's actually another package that has a more complete suite of color functions. And it's kind of a matter of taste which one you want to install. It can be annoying to have to install each of these individually. On the other hand, it means that your code footprint is kind of minimized in size, which is why people like this this whole like just like really small modules that don't necessarily have many dependencies model.
And sort of a follow-up question. Within like a package, are there generally how many like modules or exams, or are they kind of like synonymous, such as again one package is just one?
You're right that you can have many modules in a package, right? Because the package is just this like folder, right? And that can have a bunch of JavaScript files in it. Each JavaScript file is a module. That varies more because it's actually less costly to put a bunch of files together in one package than it is to put a bunch of functionality together in one file. You have no choice but to run the whole file when you require it, but you can get a big package and then just require one file out of it. That's fine. And so that, I think, varies more. There are usually still only a couple of like public-facing modules in any given package, I would say, with the exception of modules where they have like a lot of themes or a lot of something. So like Highlight.js is a module that does code highlighting, so you can give it a block of text in some programming language and it will return the HTML of it all like prettified and colorified. And that has modules for each language that it supports and also each different styling that it can support. And that kind of makes sense.
So
Yeah.
are those like package modules, are they almost kind of like gadgets? Like if you bought a computer and you just add a bunch of extra stuff to it to make it like you don't necessarily need them, but they're there if you don't want to just do yourself.
Are gadgets a Windows thing or wait?
I don't know.
It's
Just
just
like
like
it's
anything.
just
Just
like a
a
real
general-
The old school version of it,
yeah, like it,
like stuff.
yeah, like things like
Oh yeah. Yeah, basically. They'll come, it's sort of like coming with batteries included. So yeah.
Going back to our like hello.js file, so basically when we were talking about how when it requires, say, like the print array module, and we were talking about like it had the side effect of console, if you put a console log in there, it's not a function. When you require it, it runs that module, so it has the side effect of putting it to the terminal. And then that gets put to the required cache. Is that correct?
Yeah, the module that's created for this file gets put into require cache. Yeah.
Would there ever be an instance, or is it ever common? Like, can you access the required cache from the hello.js file and like work like it?
It's very, very rare to access require cache directly, and in fact, if you ask many fellows or instructors or like seniors about it, many of them won't know what you're talking about, because it's like kind of an internal thing I brought it up mostly so you can see some of the internals and also be able to. There are very, very rare and specific cases where you'll use it. Like in some programs will clear the required cache in order to get to like re-require something that has already been required and get it to run again. But those, if you're doing that, you're doing like some live reloading framework thing where you like want to guarantee that you're getting a fresh version of a source file. It's like an almost never thing in terms of touching it.
But
You could. You definitely could.
from within that like
Yeah. You could go and figure out. I think there's also like require.resolve. Is that a thing? Yeah. So you could ask like, hey, if I require util.js, what would so if I were to require this, what path would I get? And require says, oh, it's this one. And so I could be like require.cache of that. Oh, I know that I have not required this yet. And then if I do actually require it, and then I access it, here's the module and here's the exports. There they are. So it's doable. There's something is almost certainly wrong if you're like accessing required cache this way. Maybe it's something that must be wrong in order to serve a greater good though. But but it's like digging deep into the plumbing. Oh yeah, we were gonna do one small thing. Are we out of time? Oh, we're way out of time. This has been too long. Okay. You're going to get to see an example, and I think actually, wait, it is actually this example. Writing this is part of the workshop tomorrow. I just remembered, so I'm not going to do it. But, yeah, sorry, Monday. Yeah, you have no workshop tomorrow. Or maybe you have a CS Saturday? You do have a CS Saturday. All right. So thank you for your patience. What do we have after hot seat? Oh, so the mixer is about to start. Oh no. Oh.
We have like 20 minutes.
Oh, for hot seat?
Yeah.
Oh.
Mixer starts at 5 and it's 5 to 5.
Oh, okay, great. Let's oh, did we set that room? Let's do a very quick hot seat. I think Karen and I will go, and we might not have time for anyone else, but that's okay. You can find out what hot seat is. Thank you for sitting through that extremely, way, way longer than I thought it was going to be lecture. And yeah, hot seat in 5. Take a break, stretch your legs.